600 to 700 million years ago, the Earth was a giant icy snowball. A global ice age turned our blue planet into a white one, frozen from pole to equator, oceans sealed under miles of ice, volcanoes gasping through frost, and life, it barely clung on. This condition of our planet was named Snowball Earth and became one of the most extreme events in our planet's history. Scientists believe the temperature dropped so low the entire planet was locked in ice for millions of years. Even near the equator, sunlight just reflected off the snow. The Earth became a giant freezer. In this video, we will address whether the Earth can freeze over again, given that it has done so in the past, and why did Earth actually freeze? It sounds like the plot of a sci-fi movie, but it's one of the most extreme events in our planet's real history. Around 650 to 700 million years ago, during the Cryogenian period, Earth experienced not just one, but possibly two or more global ice ages. To understand what happened, we must first understand the forces that keep our planet warm. At the center of this balance is carbon dioxide. It acts like a blanket, trapping heat, warming the planet. Volcanoes act as a natural source of carbon dioxide, steadily releasing it into the atmosphere. Meanwhile, slow-moving processes like rock weathering work in the opposite direction, gradually pulling carbon dioxide out of the air and locking it away in the Earth's crust. But during this period, Earth's balance was thrown into chaos as the supercontinent broke apart. Newly exposed rock began absorbing CO2 at a much faster rate than usual. Like an overactive sponge, rainwater washed carbon from the air, locked it into minerals, and quietly cooled the planet. And there was another problem. Volcanic activity had decreased. With fewer eruptions, less CO2 was entering the atmosphere. Earth's natural heater was slowly turning off. During this frozen chapter of Earth's history, life persisted, though in its simplest forms. Bacteria thrived, along with algae and primitive unicellular organisms known as protists. But there's something remarkable about this era. Fossil evidence suggests that the first multicellular animals may have emerged during this time, perhaps something similar to modern-day sponges. Why they appeared then, of all times, remains a mystery. Some scientists believe that the extreme conditions of Snowball Earth played a surprising role. With the planet locked in ice, ecosystems would have been isolated, cut off from one another, trapped beneath frozen seas, or clustered near hydrothermal vents. And in these isolated pockets, something extraordinary may have happened. It's possible that this separation created the right conditions for cooperation. Cells that once competed for survival may have discovered an advantage. In working together, altruistic behavior, where cells specialize and support one another, could have offered a new evolutionary path. Over time, these groups may have evolved into the very first multicellular organisms. But Snowball Earth still holds secrets. Recent research has challenged some of our long-standing assumptions and opened the door to a new understanding of this icy era. For example, was Earth truly a frozen ball, or was it something more complex? Some scientists now argue that Earth may not have been entirely frozen solid. Instead of a planet sealed tight in ice, it might have been a slushball Earth with thick ice at the poles and a band of thin ice, or even open water near the equator This small strip of liquid water would have created a refuge, a thin equatorial lifeline where sunlight could still reach the ocean, and where photosynthetic life could survive. If true, it would mean life didn't just survive underground or near hydrothermal vents. It could have continued evolving in shallow surface waters, even during the coldest periods. For millions of years, Earth remained frozen, its surface locked beneath a shell of ice. But the planet was not silent. Deep underground, volcanoes had never stopped erupting, with no plants or weathering to pull carbon dioxide from the atmosphere. CO levels slowly built up, rising higher and higher, until finally the balance tipped. Greenhouse gases thickened the atmosphere. Temperatures began to rise, and the ice, kilometers thick in some places, began to melt. What followed may have been one of the most violent transitions in Earth's history. As the ice retreated, oceans absorbed the heat and released even more carbon. Massive floods carved new landscapes, and a planet once white with ice was suddenly drenched in warm, greenhouse-rich air. Earth had gone from a snowball to a sauna. But one question remains. If Earth froze before, could it happen again? In the distant past, long before humans, even before the dinosaurs, Earth's climate was controlled almost entirely by geology and natural cycles. Ice ages, volcanic winters, warming periods, all driven by the slow rhythms of the planet. Something is different. Human activity, especially the burning of fossil fuels like coal and oil, is exerting a force on the planet's climate stronger and faster than most natural processes. Snowball Earth teaches us something profound, that climate is not static, that change can come slowly or all at once, and that our planet is capable of incredible transformations, both devastating and life-giving.